Hi students, welcome to lesson on exercise 5, the radical functions and transformations on the radical function. Okay, so this is one of the first parent functions we're going to learn this year. This is y equals square root of x. This is a radical function. For the first time we sketch it, let's just use a table of values over here, plug in some x values and see what the y values come out. Don't forget, we're just taking the square root of them all. So let's start with negative 1, for example. So if you take the square root of negative 1, well, you can't take the square root of a negative, and that's something you should remember. Can't take square root of a negative, therefore there is no value of y when x equals negative 1. Alright, so let's go all the way to 0, because that'd be true for any negative value. So you plug in 0, take the square root of 0, well, that's pretty simple. It gives us 0. Okay, maybe go 1, and since it's a square root, just to be nice and easy, let's take perfect squares, because we know the square root of 1, we know the square root of 4. Okay, so here square root of 1 is 1, square root of 4 is 2, and you can keep going, right? If you had a 3 there, the square root of 3 is about 1.7, so that's why we're looking with perfect squares. And to sketch the graph, okay, so we have the point 0, 0, that's a point, we have the point 1, 1, it's a point, we have the point 4, 2, that's all we're really going to put on this graph, and the graph looks something like this. So it's actually a half parabola, horizontal. Okay, so imagine your parabola. It's basically the exact same thing, except horizontal instead of vertical. All right. So as a note, and I just mentioned this already, the values of x cannot be negative since you can't take the square root of a negative value. Also, since it's a function, each value, x value, only has one corresponding y value. Okay. We'll talk about that a little bit more in class. Alright, so characteristics of this function, the domain, this is a proper notation, so for all values of x, x is larger or equal to 0, x is all the real numbers, which means x isn't just 0, 1, 2, 3, 4, it's all the values in between as well. Okay, so we'll talk about that notation in class too. Another way to write it, it's interval notation, it's from 0, so you include 0 all the way to infinity, not including infinity. Same thing for the range. Okay, so notice that all the y values are larger than 0 or from 0 to infinity. Okay, so that's just a characteristic of this graph. This is a function. Not only should you remember that, but you should probably know how to sketch it if you're not sure. Okay, so the other half of the parabola, so I just mentioned that the shape is like a parabola. The other half of the parabola is actually represented by the function y equals negative square root of x. Okay, so another way to do that, if you're talking about what we've learned already, this would be a reflection, right? This is in front of the function, so it would be a reflection over the x-axis. So all the negative or positive y values become negative. So if I was to sketch this function right here, it would be the exact same function except a reflection over, oops, that point's not right, is it? Sorry about that. This point should be right here, 4, negative 2. And let's see if I can connect this graph well enough. So there we go. That's better. Okay, so there'd be a perfect reflection over the x-axis. Notice that the domain of this function would not change. So the domain would still be from 0 to infinity, right? But the range would be from negative infinity to 0 because it's all the negative values. Okay? For the next page, we're going to take the parent function, y equals square root of x, and we'll make some transformations on that. And I hope you guys can start recognizing the different types of transformations here. Here, it's this plus 2 is attached to the x. So here, you would have a transformation of 2 to the left. So you would take the exact same function, square root of x, and everything would be moved over 2 to the left. So remember your radical function. Okay, so your point at 0, 0 becomes negative 2, 0. The point at 1, 1 becomes negative 1, 1, and the point at 4, 2 becomes, well, the point 2, 2. And your function would look something like this. Okay, so very, very similar graph, just move 2 to the left. All right, same thing again. Okay, we have another transformation now. Notice that it's a square root of x, and it's negative 1 on the outside. So this is a vertical translation. So we're going down 1. Again, same thing as what we did before. So you take your original function we drew on the other side, and all you do is take all those points and go down 1 for each. And there's your graph. All right, so using the given equations, explain the transformations needed to perform the graph y equals square root of x. So we're going to take this as our parent function again, and we're going to make transformations that are necessary to sketch this function. All right, so I've named them all. We're going to go over them. So this negative here in front of the function, that's reflection over the x-axis, right? The vertical stretch by a factor of 2, that's 2 on the outside of the square root, and then we got 1 shift left. If we were to sketch this in function notation, it would look something like this. Y equals to negative 2 f of x plus 1. And that's if y equals to square root of x is your original f of x equals square root of x, your original function. So this is this negative, this 2 is over here, this plus 1 is over here. So you should start seeing some similarities in the two. Okay, so now we have to perform these transformations, right? So I'm just going to draw open dots to represent our original function. So our original function passes through these 3 points. That's our radical function. Okay, so the first transformation is the negative, is the reflection over the x-axis. So these would be our resulting points. That would be first transformation. And now the vertical stretch by a factor of 2. So that means times y by 2, right? So this point would stay here. This point would now become negative 2. And this other point here, sorry, the graph doesn't go big enough, but this would become negative 4. So let's guess that it's about there. Okay, and the last horizontal shift 1 unit left. So I'm going to have a final graph here. Let's make it green so that we know which one's which. So this would be a final point here. This would be a final point here. And we're going to kind of imaginary. This is a point here. And this would be our graph. Perfect. Okay, so the last thing we're going to do, just state the domain. Notice that the only transformation that had anything to do with the x values, okay, so that's any transformation here, because that's where the domain is attached, is just 1 unit to the left. So before we were from 0 to infinity, so now our new domain is negative 1 to infinity. Okay, next example. Once again, just like we saw in the previous exercises, notice that you have a 2x minus 4 here. Whenever you have a number in front of this x, we want you to factor it out, so that way you can identify each transformation. So the first thing we're going to do is we're going to rewrite this with the factored out form. So you have square root of 2, and you have x minus 2, because don't forget we're factoring out the 2 from both of the terms inside the bracket, square root, and then we have a plus 1. Okay, so that's what we're going to sketch. So again, going back to our knowledge of transformations, the 2 here that's multiplied, this divides all the x values. So another way to write it is a horizontal stretch by a factor of a half. That would be the same thing, and we're going to write it down. That would be the same thing as a compression. Sorry, compression by factor of 2. So it's dividing by 2. At the end of the day, whether you want to call it by a stretch of a half or compression of 2, that's the same thing. So that's what this 2 is. Now this 2 over here, this is moving 2 units to the right. Right? This is a translation. So a horizontal shift right 2 units. And this is vertical shift up 1 unit. Okay, so that's what we're going to do to our original function. Again, for the original function, I'm going to start with my 3 points that I know. I know these 3 points of my original graph. Okay, so this first 2 here divides all the points by 2. So the x values by 2, sorry. So now the x value is 1, it's now a half, and now the x value is 2. So that's my first transformation, right? That's the horizontal stretch by factor of a half, or compression by 2. Horizontal shift 2 units right. So all these points move over 2 to the right. Those 3 points. And then we shift up. So final graph, again I'll use a green color. So 1 up, so our final graph would be here, here, and here. And your graph looks something like this. Okay, the domain, notice that we did move this graph left or right, so the domain will change. And the domain, just looking at the graph, you can tell that it's from 2 to infinity, not included. All right. Next one, sketch the following function. So same idea, we're going to write it in terms of the function we like and the way we see it. We're going to bring this one over here on the other side, and again, there's a number in front of the x, there's a negative here, so we're going to factor the negative from the whole square root. So what that's going to look like is we're going to have y equals to square root negative x minus 2, because don't forget we factored out the negative, which means that it's now negative 2. Again, if you can just expand this to check if it works, this is negative x, and this becomes positive 2. Same thing. And don't forget we have this negative 1 at the end here. Okay? So without stating all the different transformations, I think we can just describe them as we go here. So this negative here, notice that it's inside the square root, it's attached to the x. So this would be a reflection over the y-axis. So this is a reflection, of a horizontal reflection. So the first thing we're going to do, again, we're going to start with my 3 initial starting points. This is our radical function. We're going to make the reflection. So now that point doesn't change. That point becomes here, and that point goes over here. So that's the first reflection over the y-axis. Now we've got a transformation here, a translation 2 to the right. So all these points go to the right. So move 2 to the right. So we got here, we got here, and we got here. And the last one, pretty easy one to boot. You got minus 1, so it's going to go down 1, and we're going to get a final graph of here, here, here. And you can sketch. Try to do my best to sketch a good graph here. That's not bad. And there's your graph. Again, looking quickly at the domain, you can easily tell that it's from negative infinity. So notice that the reflection here changed it from, instead of 0 to infinity, from negative infinity to 0. And we're going all the way to 2. And that's included. Okay? So last example, the fourth example here, we're given a function. You can see the radical here. Okay? And I want to actually know what the equation is of this function. Okay, a couple things you need to recognize. Notice that normally we go this way, right? The radical function goes to the right. Now this one's going to the left. So what was necessary there? Well, I think hopefully it's somewhat obvious that there was a reflection here, and there would be a reflection over the y-axis, which means your value of b, right? The number in b, that would be a negative number, because that's where the reflection comes from. We also know we moved over 2 to the right, and we moved 1 down, because this one was here, and now it's the vertex, or the end point used to be here, now it's over there, so move 2 right and 1 down. So simply, without working too hard, let's take a look at what that would look like. Well, the value of a, this would be a vertical stretch, right? Well, notice that the points normally are 0, 0, 1, 1, and 4, 2. Well, that same relationship still exists, right? 1, 1, and 4, 2. So we didn't stretch it horizontally or vertically. So those numbers would stay the same. So you would have negative, because there was a reflection. We moved 2 to the right, and we went 1 down. Notice that this is actually the same graph as we did in example 3. Maybe you recognize that or not. Okay, and just note, as final note here, this equation here, y equals a square root of b x minus h plus k, that would be the general equation of a radical graph. A, b, h, and k would be the transformations on it. Very, very similar to what we did in the transformations unit. The only difference is, instead of f of x, you have this square root function, which is the original parent function of our graph. Okay, good luck with exercise 5, guys, and again, see you in class.